Assalamualaikum and hi everyone. Today our group will be presenting on the population growth in Turkey. Let me first introduce our group member. Starting from the left, we have Damia, Genevieve, Farahia, Kasih, Irfan, and Zafran. First, we will begin with a brief introduction. This task is carried out to fulfill the assignment objective, which mainly focus on the application of the first order differential equation in modeling population growth in Turkey from 2006 to 2026. The fundamental idea of the Malthusian model states that the growth rate population is proportional to the current population. This can be expressed as the equation dP over dt is equals to Kp, where Pt is the total population at time t and K is the constant of proportionality. Using this model, we aim to predict both the future and the past population value in Turkey.
Alright, moving on to the data of table. So, this is the actual population of Turkey data from 2006 to 2025, which is a period of 20 years. This data is taken from authentic data, which is we can find at www.world.meter population. So, as we can see at the data of table from 2006 until 2025, we can conclude that the actual data population is slowly increased years by years. That's all from me.
So now I explain about the calculation process. So the population growth can be represented by the first order differential equation, which is dP over dt equals to Kp. This equation means that the rate of change of the population is directly proportional to the current population. Here, P represents the population, T represents time, and K is a constant known as the growth rate. So to solve this differential equation, I use the method of separation of variable, which is first I rearrange the equation, which got 1 over p dp equals to k dt. So, and then I integrate both sides, which give ln p equals to kt plus c. And then I convert it into the exponential form, which is p equals to ae to the power of kt, where a is a constant. Next, I substitute the data given to find the value of a and k. From the data, when t equals to 0, the population is 700,45349, and then when we substitute it, we got a also same with the population of p, which is 700,45349. And then I use the second data point, which is when t equals to 1, the population is 700,750,589. And then when we substitute into the equation, I got the value of k, which is 0.01. So the particular solution will be pt equals to 70045,349 to the power of 0.01 t. So next, I use this model to predict the future and the past population value. So for the future value, I choose t equals to 2. So when I substitute it, I got p equals to 71460,359. And then for the past value, I choose t equals to negative 2, and then I also substitute it into the same equation, and then I got p equals to 63658,358. So from this result, we can see that the population increases over time because the value of k is positive. So this confirms that the model follow an exponential growth pattern.
Alright, moving on to the graph. So for this graph, we have the graph of actual population in Turkey, and we have plotted from the year 2006 to 2025, which is T0 and until T10. Meanwhile, here we have the graph of particular solution for growth population in Turkey. Here is a graph comparing between the actual and estimated value of the growth population in Turkey. Here is a more zoomed out version of the graph comparison. As we can identify, we can still see the difference in value between the theoretical and mathematical value. It is quite a large and inconsistent difference.
So now, let's go through the discussion. After comparing between the particular solution data and the actual population data, it reveals a clear lack of consistency, while the mathematical model assumes a constant and linear growth. However, the real-world data is far more dynamic. Specifically, from T0 to T5, the model is relatively accurate. However, from T5 onwards, the actual population surged significantly above estimation. Toward the end of the period, we see that it begins to level off, suggesting that the growth rate is slowing down and returning toward the model's trajectory. So, to measure the accuracy, the percentage error was calculated. We calculate the percentage error by taking the sum of the estimated value minus the sum of the actual value over the sum of the actual value and times it with 100, we will get 3.44% error. While a 3.44% error is mathematically low, in the context of Turkey's population with approximately 85 million souls, this represents a discrepancy of nearly 3 million people. The graph shows that the model consistently underestimates the population during the middle years of the study. So, why does this happen? The calculated values represent a mathematically perfect estimation. This model assumes an ideal environment where the growth rates remain constant. In contrast, the actual values represent an unpredictable environment where the rate of change is influenced by external shocks and shifts. Several reasons and factors why the inconsistency may be: firstly, migration. Turkey has experienced significant migration inflows, which cause sudden spike in population that a standard differential equation cannot predict. Secondly, mortality rates. Technological and medical advancements have likely decreased mortality rate faster than the model anticipated, leading to higher than expected survival. Lastly, resource constraints. The leveling off seen at the end of the graph suggests that birth rates may be dropping or resources such as housing and jobs are reaching the limit, creating a carrying capacity effect. So,
In conclusion, from our assignment objective, we have achieved the first order differential equation to model population growth in Turkey over a 20-year span, which is from 2006 to 2025. And the particular solution is as per what shown in the slide. And besides, we also obtain the future population value and also the past population value, which is 71460,359 and C63658358 each. And this value is obtained using our particular solution that we calculated. And we also plot two graphs using Desmos, which is model graph and actual graph. So our model graph show linear growth, while our actual graph actually project a more dynamic growth, where it increased, then it suddenly decreased. So because of this, we also calculate percentage error, which we obtain 7.44%. So this show a moderate correlation with with the actual data. So this error might be influenced by migration, mortality rate, and also economic situations of the country. So that is all from us, Group 3 from SO7. Thank you.